Hi, I needed to design a simple pan and tilt mechanism for my project, and to do that I chose these low-cost 9-gram servos as actuators. A complete design took about 1.5 hours to start prototyping it. The first version was successful in terms of assembly. There were no collisions in moving parts or there were no dimension issues. However, I needed to change the printing position for the top part. Actually, let me introduce you the parts. This is base. It has this connection arms to be mounted on any action camera mount. It also holds the base servo, and this is the top part. It connects to the base servo and holds the top servo in place, and it basically provides panning feature by turning left and right. And this is the top arm part. It will hold the attached controller using the universal action camera mount, and it will be attached to the top servo. So yeah, as I mentioned, I needed to change the orientation of top part while printing it to have layers tangent to the mounting holes, not perpendicular. Because when the layers are perpendicular with the hole, part gets cracked while tightening the screws. It was an obvious issue. However, I also had non-obvious issues. For example, I did not have any issue on first prototype, but the second time I was printing the top arm part, there was a sticking issue and the part almost failed because it wasn't sticking the bed. So as you can see, I needed to alter the design a little to give the nut holding place a water drop shape instead of full circle. And finally, I wanted to mechanically stress the base part because the heaviest load will be on this part. I tried to break it with my hands, but ASA filament was too strong to break it with bare hands, which is good, but I needed to apply further force to see if it was durable under heavy load. So I used pliers and pushed it between servo and mount to see if it will break. It got broken on the servo connection part, but I applied the force on the wrong side of the actual operation position. It won't face that much load from the bottom like this. Instead, it will be bent like this. So I applied the maximum force that can be experienced by squeezing the servo all the way to the mount body. And again, part failed at this weak point. So I added fillets to increase the strength of the part, and voila, as you can see, it bends all the way to the mount, but it doesn't get broken. So yeah, maybe we can refine it further before going into mass production, but I'm happy with the design of this pan tilt mechanism. It's easy to assemble and easy to operate. Oho! Güzel. Görüyor musun? Thank you so much for watching and see you in the next video. Bye.